This is our introduction to exercise 5E on matrix multiplication, page 234 of your textbook. We're starting off with a very straightforward addition, subtraction / scalar multiplication of matrices. You're more than welcome to do this in the calculator. You don't actually need to know how to do this by hand, but it's a good idea to know how to do so. So for the question A, or first question here, we'll be presented with matrix A, matrix B. Once again, conventionally speaking, the matrices are represented by capital letters. To find matrix A minus B, of course, all I'm doing is I'm subtracting the values from B into A. So I'm trying to make sure that the elements line up. In this case, if I'm going A minus B, I know that it's going to be 4 minus 8, which is negative 4. Negative 2 minus 2, which is negative 4 again. Negative 3 minus 5, in other words, negative 3 plus 5, which gives me positive 2. And finally, 6 minus 3, which gives me an answer of positive 3. And therefore, our answer is E. Pretty straightforward. Let's do question 2. Question 2, very similar. All you need to do is multiply the matrix A by 2 first, and then we solve it from there. So matrix A, if we find 2A, that equals 2. And I'm going to multiply every element by 2. So it's 4 times 2, negative 2 times 2, negative 3 times 2, and 6 times 2. And then we're going to subtract them to 2A minus B equals 2. So it's going to be 8 minus B, which is also 8 here, so that's 0. Negative 4 minus 2, which gives me negative 6. Negative 6 minus 5, or in other words, negative 6 plus 5, which gives me negative 1. And finally, 12 minus 3, which gives me positive 9. As per usual, you're more than welcome to use a calculator for this step. Okay, let's get into today's content. I did mention last lesson that matrix multiplication, so multiplying by a matrix with another matrix, is very different. Okay? Very different from scalar multiplication because there are different steps involved. I'm going to get you guys to write down these rules while I speak over the top. Okay, so rules 1 and 2, please make sure you write that down, and also that if you are not aware of that. Okay, so as I mentioned, multiplying by another matrix is drastically different from scalar multiplication. There are 2 rules that we need to make sure we are aware of before we even begin our matrix multiplication. Does anyone remember what the rule is? What order matrix do we have to have when we're adding and subtracting matrices? What's the rule regarding the order? Has to be the same, yeah. The order has to be the same if we're adding and subtracting matrices. Now, when we're multiplying matrices, it gets a little bit trickier. Let's say I have 2 matrices. I'm going to go ahead and draw this matrix. That's a 0, 0, 0, 0. And I have this matrix here, 0, 0, like that. Okay. The order of my first matrix, Russell?
2 times 2.
Good. Taya, second one? Rose first, remember? 2 by 1. Thank you very much. So we have a 2 by 2, 2 by 1 matrix. Let's say I wanted to multiply them together. And I'm going to try to use colors to represent this. The values on the inside must be identical. So this value here and this value here must be the same. You can see it's represented here. This order and this order. The values on the inside must be the same, otherwise it does not exist. You have to have the values on the inside being the same, otherwise you cannot multiply them. Okay? If, let's say for example, I've got that, I'm going to go ahead and move this matrix here to this side. Can I multiply that? No. So, for example, if I was matrix AB, matrix A times matrix B is not always the same as matrix B times matrix A. Okay? It's not the same. So keep in mind, we cannot multiply these two because the numbers on the inside are 1 and 2. They're not the same, and therefore we cannot multiply them. Let's move it back. So I've deemed that we can multiply these. Once I've determined that, I'm going to look at the numbers on the outside. Okay? The numbers on the outside tell me what is the order of the matrix I'm going to end up with. So in this case, when I multiply these 2 matrices, I should end up with a 2 by 1. Okay? So the numbers on the inside must be the same, and the numbers on the outside gives me the order of the matrix we're going to end up with. Any questions about that? Okay, let's do some practice. Okay. I'll leave that up there for you guys. Now, you don't actually, once again, you don't need to know how to do this by hand. I'm going to go through one of the examples by hand just to show you how you would do it by hand. But at no stage in this year do you need to do any matrix multiplication by hand in order to get full marks. The only reason you want to know how to do matrix multiplication by hand is to understand the process behind it, because there's a lot of application style questions regarding matrices. So we're given a series of matrices, all with different orders. We need to decide whether the matrix multiplication in each question is defined, so whether it exists, and then if it's defined, give the order of the answer and then do the matrix multiplication. So you don't have to do this every time. This is just what I like to do. I'm going to write down the order of each matrix, okay? So I know that's a 3 by 2 because it's 3 rows, 2 columns. Remember, always rows, then columns, okay? 2 by 1, 3 by 1, sorry, 1 by 3, my apologies. And finally a 3 by 1. Okay. Does AB exist? Can I multiply A by B? No. Yes or no? How do I know if I can or cannot? Yes, why yes? Because, good, the two numbers on the inside are the same, and therefore I can multiply the matrices. What would the order be of the final answer? 3 by 1. Whatever numbers are left on the outside, 3 by 1. So the answer, AB, should be 3 by 1. Before we find that, let's move on to the next one. BA, does that exist? No, why not? So I would go BA, so B, and then A is on this side. Are the numbers on the inside the same? No, therefore it does not exist, or is undefined. What about CD? Yeah, CD does exist because I've got 3's on the inside and I've got 1's on the outside, and therefore my final matrix answer should be 1 by 1. Does DC exist? Yes. Yes? Okay, sweet, good. Let's continue. All right, let's try and solve it. Now, I'm going to do this, I'm going to try my best to explain it. It's very weird. The process is so much more complex as it needs to be, but let's go through it. AB, I'm going to actually write the matrices out. You don't have to write this out. This is just so that we can break it down a little bit easier. So 5, 2, 4, 6, 1, 3, and 8, 9. Now I know that my final answer is going to be a 3 by 1 matrix, don't I? Okay, so I'm going to go ahead and try my best to draw a 3 by 1 matrix, and let's try to understand it. So the first value, the value that's meant to be fitting into this element right there, is our row 1, column 1. Agreed? Yeah. So row 1, column 1. I'm going to pick the row 1. There we go. Row 1, column 1. Okay, always row, then column. Okay. So pick the row and then the column. The first number I get is 5, and the second number I get is the 8. So I'm picking the first number of the first row and the first number of the first column in the second one. Okay, so I'm going to write that out. I'm going to write 5, and I'm going to multiply them together. 5 times 8. Now the number, remember in this one, it's still row 1, column 1. So what I'm going to do next is I'm going to multiply the 2. Oops, let's get rid of these blue circles. Multiply by 2 by the 9. Okay, so I'm going to write 2 times by 9, and I'm going to add them together. Okay, the idea is each number should be interacting with another number in that row / column. So we've actually filled in the first element. The second element is in the second row, first column. That's where this one would be. Yeah? So it's going to be second row, first column. I'm going to do the same thing. I'm going to multiply the 4 by the 8. So 4 times 8. And I'm going to do the same thing over here, 6 times by the 9. A common way this is described is we run across the rows and dive the columns or whatever. It's the same idea. So we pick the first value of each one, and you notice it's kind of like a weird shift towards the right. Pick the first value here of the second column, so second row, my apologies, in the first column, and we switch it down. Now this one here, what position is that in? Third row. Is it still first column of the second matrix? It is, good. So I'm going to pick the third row, first column. I'm going to multiply them together. 1 times by 8 and 3 times by 9. And then we just write the pluses in the middle. Okay. From there, same thing applies. I'm going to go ahead and simplify it. So 5 times 8 plus 2 times 9 gives me 58. 4 times 8 plus 6 times 9. That's 32 plus 54, so that's 86. And then finally, I've got 8 plus 27, which gives me 35. Now, order-wise, does that look right for our matrix? Is it a 3 by 1? Okay, good. So we haven't screwed up anywhere majorly. That's the process that's involved for multiplying by hand. I want to make it very clear, you do not have to do this in an assessment. You will always have your calculator with you. Okay? I'm going to skip forward to the next example, but I'm going to leave that up on the screen for you. This is an example of matrix multiplication by calculator. It's exactly the same thing you guys have already done. Of course, if it doesn't exist, the calculator can't do it for you anyway, so just make sure it exists before you put in the calculator. In this example, we've got a 2 by 3 matrix and a 3 by 4 matrix. It'd be very annoying to do by hand. So you do the same thing you would with addition, subtraction, of course, and you'd do a multiply instead of a add or subtract. That's the only difference. Okay. After I stop the recording, I'm going to do another example of matrix multiplication by hand. But for now, if you feel like you're ready to give the questions a go, I'd like you guys to get started on the exercise questions.